what if we'll have a figure like this? No? So I'll call this figure now, no, as a composite figure. No? So what if we'll have a composite figure? No? So I call it as a composite figure because basically we can split this, no, and make it into regular figures, no, regularly shaped figures. Like we can draw a line, for example. No, I'm going to draw kind of a line. No? So if I'm going to draw a line somewhere here, you will realize nga pwede ko ni siya ma-cut and make it into two regularly shaped figure now. No? So I'll end up now with basically two rectangles. No? So I can either draw a line like here, dire pa kadto. I can also draw a line, no, from the top going down. No? Now again, no, it's up to you. No? So you have to decide which way you will cut, no, or you will draw a line. No? Now as to the number of cuts, your goal when you have to cut it, no, into regularly shaped figure is that you have to cut it in such a way that you will end up with the least number of cuts. No? So the original shape was a letter L, no? Something like a letter L na figure. It's an inverted letter L, no? And there's no line here initially. Now, I added here this blue line where I call now this blue line as my axis. No? So I have now the Y and I will have the X axis here. No? So again, no, from our original shape, I cut it, no, into two. No? So again, no, the goal of cutting it into two, I have the least number of cuts. No? I can actually end up with three cuts. No? I can have more. No? But the goal is to have the least number of cuts. No? Now, we did not add a dimension here. No? Let's say we will have a dimension here. No? So let's say this side is around 4. No? And perhaps this is something like a 4 by 4 figure. No? Somewhere here, this is 2. This side is also 2. This one is probably 2 also. No? So originally, amo na yung dimension. No? So the sides are basically tag 2 units. No? Ang ining daw letter L. Now, our question is, where is now our CG here? Now, where is our center of gravity? No? Now, again, initially, again, there's no line here. Since wala na isang line, then we simply decided not to add a line. Oh, sorry. I'll use the red mark na lang. So again, this is a 4 by 4 square, but somewhere here we cut it now into 2 by 2. So ang aton pamangkot this the CG. Where is now the location of the center of gravity of this figure? Now again, we decided to cut this somewhere here. So by cutting it there, no, we end up with two sets of figure. No? So we could have, no, let's say figure A. No, I'll call the one at the top as figure A, and the one below as figure B. No? So that I will know the two sets of figures that we have. No? So in terms of our figure, again, we have figures A and we have figure B. No? Now, aside from the names of the figure, we will write probably, no, our X bar and our Y bar. Do you remember the meaning of X bar and Y bar earlier? Ha? Dumduman niyo pa tong X bar and Y bar kaina? What's the value of X bar and Y bar? Ano ni sila gani?
Axis.
This is our center of gravity, no? That's A na. Now, if you're going to draw, guys, no, a diagonal at our two figures, no? Mag-draw kita di sa atong diagonal sa atong duha ka figure. So for our figure A, I'll draw a diagonal. For my figure B, I'll draw also another diagonal. What will be the CG of our figure 1 or figure A? No? Ano niya nga center of gravity dire? No? So if we will try to locate no, a center of gravity, anong yung center of gravity sa figure A? No? So basically, this is the origin 0, 0. So if you'll try to locate this one, ano ni iyang value? No? If you project this downward, no, what will be the location of this figure? No?
3, sir.
So half of 4 is what? What's half of 4?
2.
2, sir.
No? So ang iyang x value kay horizontally 4 na siya. So half of 4 is 2. So we will realize that you'll have here an x value that is equal to 2. No? Now, how about ang iyang y value? No? So from this end. No?
3, sir.
So if this is 2, half of 2 is 1. No?
1.
But from the origin, this is already 2. 2 plus another 2 gives you what? 2 plus 1.
2 plus 1, 3, sir.
Gives you 3. No? So this coordinate is actually 2, 3. No? So that's for figure A. No? Do you follow? Now what about our figure letter B? What is the location of the CG of figure 2? No? So figure 2, this is a 2 by 2 rectangle. Actually, it's a square. Okay? It's 2 by 2. So half of 2 is what?
1.
So it's 1. But from the origin, anong iyang coordinate dire?
3.
3.
Basically 3. Ang iya x. No? The x value is 3 because starting here, this is 2 plus 1. So the coordinate is basically 3. No? Now, again, now the height is 2. So half of 2 is what?
1.
1. So if you project it on the y-axis, what's the y value of our figure B? No? Anong iyang y coordinate?
1.
1.
No? So basically, this is 3, 1. Hindi nga point is 3, 1. This point is 2, 3. No? Are you following me?
Yes, sir.
Okay, now, aside sa sinanga value, guys, no, we are going to get our area. No? The area of figure A. What's the area of figure A? No? So figure A is the one at the top. This is 2 by 4. So 2 times 4 is what?
8.
So you have an area of 8 square units. No? So this is 8 square units. What about our next figure sa dalong? It's a 2 by 2 square.
4 square units.
Sorry. This is 2 times 2. So that gives you
4 square units.
Square units. And what's the total area? Total area.
12 square units.
So the total area is equal to 8 plus 4 is 12. 12 no? Square. Okay, again, now please remember the areas of A and B and the total area of the whole thing. No? Now, to find the CG of the whole figure, no? So hindi pwede na separate nato. We could not have two separate centers of gravity for this whole figure, no? Isa lang ang iya center of gravity sini, but if you try to slice it, no, then amoning duwa ka center of gravity yan. But as a whole, there's only one value for that, no? And how do you calculate ko no sang iya nga x bar, no? The x bar literally of the whole figure, no? Nang ina ko nung iya x bar, guys, no, is the product, no, sang iya nga area 1, no, i-multiply sa iya nga x1 nga value, x bar 1 nga value. So 8 will be multiplied by 2, no?
16.
Ang iyang area 2, ang area 2 nga figure, i-multiply man sa x2 2 no nga value naton sang B, no? So area 1 or area A no times 2 and then 4 times 3, no? Now ano atong denominator kay i-divide ta ni siya kuno, no? So our whole denominator is actually no our A sub T, no, or area total, no? Ilang total area gani naton?
12.
12, no? So we will divide it by the whole area, not 12, no? Okay, so calculating, so this is actually our x bar of the whole figure, no? So how much is our x bar? Again, our x bar value is 8 times 2, no? Plus 4
4
times
times 3.
3, no?
Divide
Divided
12.
by
12.
12, no? Okay, so please calculate.
2.3, sir.
So our value is equivalent. So this is x bar. Ha? So the first coordinate natin is equivalent to, again, how much was the value? 2.33,
3.
no? Okay? So kung sa x-axis na, if this is basically 2 and this is another 2, so labaw di siya gamay. Oh. So somewhere here, somewhere at this point, no? Dire ko na mo niyang 2.33, then this is where the x value is located. No? So this is now 2.33 na location. No? Now, what about our y value? Our y or y bar, no? Our y bar for our whole figure again is a1 times y1. No? And then a sub 2 times y sub 2. Again, y sub 2 is our y coordinates of our figure. So, what's the goal of having to cut this into less number of figures? Again, for lesser computation. More cuts, guys, will end up nga laba-laba na di karon ng numerator mo. No? Do you see the point?
Yes, sir.
Okay, so again, now the lesser cuts will allow you to solve less number. No? Okay, now, calculating. No? So we have, pila to? A1 is 8 multiplied by 3. No? So 8 times 3 plus 4 times, ano?
1.
4 times 1. Divide by,
12.
12 by 12. No? Okay, so we have our figure. No? So let me draw a line here. So this is our division, and then again, this is our y bar. No? Now, our answer, is it the same? 2.33 man.
Yes.
Yes.
Our answer is basically, no? 2.33 man gali gyapon. No? So, meaning, if we are going to draw our another line here, so labaw man di siya gamay sa babaw. No? So, if this is 2.33 nga line, then where is the location of the CG? So the CG is somewhere here. No? It is within our given figure. No? So this is karon nang iya nga location ng CG. Okay? Now, we can actually do this, or we can actually find this, no, without having to solve this one. We have an experimental method of doing it, no? And actually we can use, no, a string and a certain weight, no? We call that string and a heavier mass as a plumb bob, no? Or a plumb line, no? Abati na kamas ang word nga plumb bob, plumb line.
Sa tubo.
Ha?
Sa mga tubo, sir.
Sa tubo, ang plumber na iyan, no? Lain mo na yung plumber. Ang plumb bob ya, guys, may ara kabi nga metal, no? You have a metal, no? that metal will be suspended by, no? So kung metallic niyo, no? Let's say I have a metal there. Butahan ko na sa isang higot diyo, a string. You'll notice that when I suspend it with a string, it will always be straight downward, tama? No? Amo ning ginausar sa mga panday bala, no? Ibutang na nila ang ininga metal with a string, no? Side by side to a column, no? May haligi kada binaw nga ginalantaw nila kung tadlong ang haligi o kung hindi, no? So again, no? They check it with a plumb bob or a plumb line, no? Now, kung may ara kita nga activity nga similar to this one, no? We can actually connect this plumb bob or plumb line at one corner, no? Let's say I'll choose two corners for this composite figure. No? Let's say I'll cut a cartoon, no? Or a piece of cardboard, no? And I'm going to pin, no? I'll put a pin on one corner and I'll hang this string with a plumb bob, no? So ang ining metal at the tip is called as a plumb bob. I can suspend, no, that plumb bob on this figure. So I'll make this rotate on the pin, no? Once it is now resting, I can connect this, no? Now the line created by this one, no, to this figure, pwede na ito na drawing on by this plumb bob, no? And again, no, position it now in another point na naman, no? So ga-choose kita isang corner actually, no, if we choose a plumb bob method, no, in locating a particular point, no? Now I'll illustrate it. For example, if I'm going to switch on my camera, no? So I'm going to remove this one for a while. No? I'll stop sharing that. No? So if everybody, no, will try to look at this box that I'm holding right now. No? You see the box that I'm holding?
Yes, sir.
So this is this
Yes,
box.
sir.
No? So you'll notice that if I'm going to pin this box on one corner, no, that there's a tendency for this box to rotate, no? That, no? So there's a point or a location where this one will rest completely. So if I'm going to do it like this and I'll put the pin somewhere here in this corner, this one will not rest completely, no? Because I have to grip it with my finger so that it will be positioned like that. But if this one is free to rotate, no? If this is free to rotate, may harap ni siya position where this one will rest completely. Do you follow? Butang ko dabla sang needle, and I'll allow this to rotate freely. No? There's a position for this box to be at rest. No? So siguro, maniguro yung position. If I'm going to get a string, no? If I have a string and a pin, atong plumb bob, ang inikaroon nga string or plumb bob will now create a line, no? Here, no? Sa ini nga box. Now, by the plumb bob method, we can actually trace that line created by the string, no? So if I'm going to get a ruler and a pencil and trace the line created by the string and the plumb bob, I'll draw a line across the box. Now, if I'm going to remove the pin and put it on a different corner, no? I'll put it on a different corner. And again, do the same thing now, make it rotate on the pin and until such time it will rest completely, no? Nga nagaway na siya nagahulag bala, no? This is its equilibrium position. I'll transfer the plumb bob, the string and the metal on this position of the pin, and you'll notice nga matrace naman na sa another line there. No? Can you picture out what I'm talking about? So may string there, now there's a plumb bob that is suspended. If I'm going to trace that line, you'll notice nga may ara na siya karon nga ma-create din nga intersection ng na plumb bob. No? There's an intersection. Now that point, now by experimental method, is probably, no, the location of the center of gravity of the figure. So actually, it's easy for a rectangular shape figure not to locate the CG. Nga gani, kung rectangular shape ni siya, then I'll just draw a geometric diagonals here. No? And actually, no, ang iyang pinaka-center probably will be located there. No? Now, the plumb bob method will trace that point. No? But if I'm going to have a composite figure na hindi siya completely rectangular, then it will be a bit more challenging. No? So, but again, no, by using the plumb bob method, you are able to find the CG also. No? Do you have a question? So, from our previous method, did you get the process? So, to locate the CG, guys, no? Ano gani ginaobra natin to locate the center of gravity? We cut, we slice the irregular shape or the composite figure into regularly shaped figures. No? You have to cut it in such a way that it will have the least number of divisions. No? So once you have that, then you can label it as figure A, B, C, or figures 1, 2, 3. No? Find its individual CG and find its area. No? Now add up all the areas and call it as the total area A sub T. No? Then you can use the equations now once you have verified all those individual CG. No? Okay, so again, no, ang aton nga ginhatag nga example, it's a very simple diagram. No? Well, anyway, any question with that one? So we are done with the center of mass or center of gravity. No? Now let's go into this thing called momentum. Ano yan sa Ilonggo ang word nga momentum? Guys, anybody would like to give an Ilonggo equivalent sang momentum? Anybody? Wala?
Tinihon.
Ano ang momentum sa Ilonggo? Mga Ilonggo ka mo kung hindi. Basta hindi ka ma-Ilonggo.
Wala man sa equivalent.
Wala siya equivalent. So, nakabati na ka mo sa word nga boilo.
Sir.
Sir.
Boilo, bala ang salakyan. Ngayon notice ako nagaboilo, kadalagan, kag papunduhon, kagulpi, no? Or may tao, dabi nga gulpi lang ma-cross sa imo, ginadalaganan, bala. So, ano matabo sa inyo when you collide? Notice nyo nga ang stana sa, no? Madalasa pa na sa sang imo nga boilo, no? Okay, so muna, no? Siguro ang equivalent sang boilo sa English is momentum. Now, in the previous lessons, we learned that mass of a body is a measure of its inertia at rest. No? From experience, the more mass a body has, the greater tendency to stay at rest. No? So kung why naman siya nagahulag, and then suddenly bungguan siya no? Ang nagapundo nga object, no? Mabungguan sang nagadalagan nga salakyan. Okay. Suddenly, no? Ang dasig nga salakyan mahina siya gulpi, and again, it will create something like a word called impulse. An impulse is a very, very big force that is created in a very, very short period of time. No? Just like imagine, no, you have an electric post. No, ang electric post nagahulag na waay. Kita mo sang poste sang kuryente?
Wala.
Nagahulag.
Wala, sir.
Wala. No? Or ang mga structure na bala like ang taytay da bino nga sa General Luna why na nagahulag, di ba? Now for some reason may ara nga isa ka auto nga nagadali gid siya drive and mabungguan nga na ang do approach ang taytay bala, no? Why na nagahulag, no? Ano matabo sa tao sa sulod sang salakyan nga nakabunggo sang poste sang inang mga structure that isang taytay, no? Iya nga daw pier da bla, no? Ang nagahawid sa taytay nga hindi bla support sa taytay. So you'll notice nga a very, very big force called an impulse will be created inside the car, no? Kaya iba nga mga auto na guys hindi na mahitsura, no? After it collides, no, with this post nga wala kang dahilan. Okay, because the force that is created is a very, very big force that happens in a fraction of a second, no? So, man ang ginatawag natin nga impulse, no? So, kung isa, it will cause death. Kaya ang ina nga force is so large, no? Okay, so please remember that, no? Again, no? Kung ang salakyan dasig or ang iya mas dako, ang iya impulse nga i-create is also a very big impulse, no? So impulse and momentum, they kind of work together, no? Or related together, no? So momentum can be observed in our daily experience. No? The greater the linear momentum of the body, the greater the effort needed to change its path, no? Or to stop the body from moving, no? Pero may ara iban, no? Si Efren Bata Reyes, kilala ka mo kay Efren Bata Reyes?
Yes.
No? So gausar man na siya sa momentum, siguro hindi gid educated or nakatapos si Efren Bata Reyes ang iya physics classes, pero naintindihan niya gid kung paano na sayluhon ang movement sa mga ano na bola sang kuan billiard, no? So kabalo sa magpa-shoot maskin do ka budlay na gid nga ipa-shoot, no? So again, no, that's also about momentum, no? Impulse, no? Usually ang value sa atong momentum, guys, is a product of the mass of the body and ang iya speed, no? So M times B, no? We call that as momentum. Therefore, ang unit ng atong momentum is in kilogram meter per second. Again, the value of momentum let me share my screen. Ang product sa momentum, let's define momentum. So momentum, we will call momentum as letter P. No? Momentum is mass times velocity, no? MV. No? So M times V, anong unit niya therefore?
Kilogram meter per second.
Okay, so kilogram meter per second. No? Wala na square, ha? Kaya ang may square to yeah, that's force. No? So this one, meter per second lang siya. No? So, momentum ko no is a vector quantity, no? So kay velocity aton gina-deal dire, no? So there's a direction for the momentum. If you're going to compare a small car and a massive truck, no, moving at the same speed, no? The smaller car, since it has a lesser mass, has a lesser momentum, no? In terms of mass, no? Kung parehas ila speed, no? So ang truck ya, since dako iya momentum, parehas lang sila kahinay ang dalagan, pero kung maipit ka sang truck na hinay ang dalagan niya compare sa auto, maybe no, a greater damage can still be done by the truck. No? Why? Sinong dako momentum? Same ila speed.
Sir.
Ang truck, no, kay dako iya mass, no? So its mass has an effect on its momentum. Maskin pa rihas ang ilang kada sigon sang pag-ulag. So it does not only it is not only affected by one factor, no? So the mass is also another. On the other hand, a shipping vessel out at the ocean, no, can have a larger momentum when it is moving, no, at a small velocity, no, because it is massive. Likewise, a very small bullet moving at a very high speed can also have a large momentum. Kung may barko, guys, nga ara sa pier, no, I don't know, no, if I remember the time nga nabunggo siya bala sa pier, ang barko. Now, ang barko once nga nagasulod na nasa sa port of entry sa iya nga dulongkaan nga pier, no, ano na nang ilang nga dalagan, dapat hinay na ila dalagan, no? At any time nga may ara da nga collision, since dako na iya mass, it can create a very huge damage, no? Okay? So amo na, no, hinay ginang dalagan sang barko kay way na saya nagapundo gulpi, no? Kita mo sang barko nga magprino pundo dayon. Wala, no? So maskin ano yan na nga reverse ang direction sang iya nga alisida, no, dugay na siya kay magpundo, no? Because of its sheer mass, no? You've seen some videos where this massive, no, nga mga cruise ship, no, will go no nga out of control bala no, nagabusina na sila no. Maski na no nang abusina nila just to inform the people on the port nga they are not no in control anymore no, and the people in the port should prepare for collision. So ang damage yung gina-create nila dako no. Now our bullet, the bullet is very very small, gamay iya mass. Pero ano ang in-increase sa bullet para nga it can be deadly?
Speed.
It can even no, penetrate through armors no. Ang iya speed no, ang speed yun naman ang dako-dako no. So again no, the effect of what we call momentum. To change the momentum of an object, either the mass or the velocity no, is changed, or both no, mass and its velocity. No? Okay, here are some examples no, probably of momentum. No? So find the momentum of a 100 kilogram object traveling at 20 meters per second. So it's merely a product. No? So if it is a vector quantity, then maybe we will consider no, the velocity of 20, whether it's going right or left, no? Whether it's going north or south. No? So something like that. No? But this time it's merely speed. So in magnitude alone, that's 2,000 kilogram meter per second. Now, is there a shortcut value for kilogram meter per second? There's none. No? So we'll just write this whole set of unit. Lain man to ang Newton, na kay second square to yan. Na? Now, the velocity of a 2 kilogram object is increased. No? So, maybe from 2, ginhimo siyang 4. No? And, ang speed gali, no? Ang gin-increase. No? So, what is the change in its velocity? No? Pila ang change ang velocity sang aton nga object karon, no? So, to get the change in momentum, I mean, no? So, delta P, no? So delta P is the difference of the velocity. So 4 minus 2 is 2. 2 times 2 is 4. So its change in momentum no, is 4 kilogram meter per second. So nag-subtract ka no? Now again, no, impulse and momentum. Again, ano to gani ang impulse, guys? Impulse is created when no, object suddenly no, encounters an obstacle and all its momentum is now converted into something like a force no, that is created at a very very short period of time. So if mass times velocity is momentum, then ang ato naman yung impulse or I is equals to the product of Ft, no? Force times time. No? But actually that value no, force is from our second law. But you'll notice that acceleration is change in velocity per unit time. No? So if you'll cross multiply time to the force, no, so you'll end up with Ft equals mass times change in velocity, and change in velocity is Vf minus V sub I. No? Now this again, now this value Ft is known as our